Okay guys, today we're going to be doing 4.6. It's called the first derivative test, but today we're just going to be doing graphically, okay? So we're just going to be looking at graphs. So let's start it up. Okay, first off, this is something that we were doing the other day. So let's just kind of remind ourselves. F of x is increasing, then f, and this is a prime, okay, that's saying f prime. If f of x is increasing, then f prime is, and the answer is either going to be like positive, negative, something like that. So if f of x is increasing, so that means that the function is going up. That means that the slope, that's the derivative, right? The slope is positive, okay? So positive is what we're looking for right here. F prime is positive. Or you could say, like how we were showing it the other day, f prime of x is greater than 0. Okay, f of x is decreasing, then f prime of x is negative. Negative. Okay, or you could say it as the opposite. F prime of x is less than 0. Okay, f of x has a horizontal tangent line, then f prime of x is, okay, remember that is a horizontal tangent line, is when you have a slope, or an f prime, of 0. Okay, so that means f prime of x is equal to 0. And remember, we call those things horizontal tangent lines or critical numbers. Okay, critical numbers. Or we could also, if you could see horizontal tangent lines or critical numbers, you could also be solving for vertical tangent lines. Okay, let's get started. We're just going to be talking about some graphs today. It shouldn't be too difficult. Okay, first thing here is I'm going to show you the first theorem you're going to learn, which is called extreme value theorem, or an easier way of writing it, EVT. Okay, extreme value theorem. It's a pretty easy theorem. It's saying if a function is continuous, okay, remember that means you can draw it without taking your pencil off the paper. Okay, continuous. Remember that is the 3 rules. It has a limit, has a point, and they're equal. So draw without taking pencil off the paper. Draw without pencil off paper. Okay, and closed. So the function is continuous and closed. Closed means that the points at the end are included. That's why I'm putting brackets here. So closed from A to B, then the function has a max and a min. Okay, let me just draw an example here on the graph. It's a pretty easy idea. Okay, I'm going to have a closed function from A to B. A to B is just some sort of numbers here. I can count them as 2 to 5. It doesn't really matter. My A to my B. And we have a closed interval. So I'm going to have closed points on both of those. And it says if it's continuous from A to B. So I'm going to draw a line that's continuous. Okay, I hope everyone would agree that's continuous and closed. Okay, if you have a function that's continuous and closed, like this one, you will have a max and a min, which this makes sense here. In this case, this is your max right here, and this is your min, yeah? So you have a max and a min. There's other ways to draw this as well. Let's draw another one. Let's say my A is going to be, -1 to 3. Okay, let's say I put a dot here, and I go down, go up, close it up. Okay, that's continuous and closed. Okay, here's my max. Yeah, here's my min. Okay, so it's saying if you have a function that's continuous and closed, you will always have a max and a min. Okay, so that's all this is saying. That's the extreme value theorem. We're going to be using that today. We're going to have all closed and continuous functions, and you're going to be finding the max and the mins. Graphically, this should be a very easy day here. Okay, first thing, let's talk about critical values. You already know what a critical value is. A critical, you can call this a number, a critical number. Okay, value means y value. When they're talking about the critical number, that means the x value. Okay, that means on these you have relative max and mins. Now notice, what a critical number is where you have a horizontal tangent line. Right there, right there, right there, right there, right there, and all these values, right? Notice that all these values are max and mins, right? So you can have, if you have a critical number, it could be a max or a min. Okay, so critical max is where the function changes from increasing to decreasing. I hope that makes sense there. Critical max, like this is a max value right here. It went from increasing to decreasing. So that would make this a max. Okay, a critical min is where a function switches from decreasing to increasing. So like here, decreasing to increasing. So this has to be a min. Okay, this will be important for tomorrow. This would be a max. This would be a min, a max, a min. Okay, let's just start labeling some of these off here. Okay, now these criticals, there could be multiple critical maxes and mins. An absolute maximum min, there's only one. Okay, so let's write that down there. Absolute max and min, there is only one. Okay, there's only one max, there's only one absolute min. Okay, so like on this graph here, your absolute max would occur at, and here I'm going to do this, it occurs at x equals 0, and the value is y equals 1. Okay, now let's also see where is the absolute min. So you would say that at this point and at this point, they have the same lowest value. So where does it occur? Now it could occur at two places. Okay, so occur at x equals, it looks like maybe about like negative 4.2, I would assume, negative 4.2 and 4.2. So it occurred in two different spots, but the value of it, there is only one value, and that value is y equals, looks about like negative 2.21 or something. Yeah. So the absolute min and max, there's only one place where the value happens. There could be multiple places where it occurs, but there is only one absolute max. Like this doesn't count as an absolute max. This counts as a critical max because there can be multiple critical maxes, but there's only one absolute max. And this is the absolute max. Okay, so critical max occurs. Okay, so since it says critical max, critical, that is telling me there could be multiple maxes. Yeah, okay, there doesn't have to be only one. And it's saying occurs, so that means my x value. Okay, so let's see here. Where does maximums occur? So this would be a critical max. It switched from increasing to decreasing. Okay, that is my only critical max. So at x equals negative 1. Okay, critical max value. Remember, value is the y. So what is the y value where that occurred? Looks like it's about 0.5 maybe. 0.5. Okay, critical min. Critical meaning many of them. There could be many. Min occurs. Occurs meaning the x value. Okay, so let's see if it looks like there's multiple minimums where it switches from decreasing to increasing. So this is a min, a critical min, right? And this is a critical min as well. So critical, try to fit it in there, and critical. Okay, and it's saying where do they occur? So the x values. So it occurs at, we'll say like about negative 4. I'll say negative 3.8. I mean, this is kind of a guessing game here because it's a graph. Okay, and then this one occurs, I don't know, maybe like 2.6 or so. Okay, and the critical min value, the value, that is the y. Where's the y values? Okay, well, let's try to make a match up here. First, I wrote negative 3.8, so let's do the y value for that one. Looks like negative 1.5 maybe, negative 1.5. And the other one is negative 3. Okay. Now we're going to go into absolutes. Like this is an absolute max. Occurs. Now remember, it could occur in multiple spots, but there's only going to be one value. Okay, so let's see. Where is the absolute max in this case? Endpoints count when we're doing absolutes. So right here, that's the absolute max. That is the largest y value there is. So the absolute max occurs at x equals 4.5. Yeah, that's about 4.5 on the x values. And the value of it, the y value, is going to be 3. There's nothing larger than that value. Okay, so let's look at the absolute min. Okay, so there's only one. That's going to be down here. It's going to be right here. So it's a critical min and an absolute. Okay, it's both. Okay, an absolute min. Now it's occurring at about x equals 2.5 or so. I think I wrote 2.6 on this other one, so how about I keep it similar? 2.6 is what we said, and we said the y value for it, what is the absolute min value for it? We said that that was at -3. Okay, let's do one more graph if you don't get it, and so you can do the worksheet. Okay, so if you look at this, let's label some stuff here before we even start reading. Okay, these are our endpoints. They're closed, right? This is a continuous function. It doesn't break. This does not count as a critical min because it didn't go from decreasing to increasing. This right here counts as a critical max because it went from increasing to decreasing. This right here counts as a critical min, and you know what? Let's do that like that because it went from decreasing to increasing. This counts as a critical max because it went from increasing to decreasing. This does not count as a critical min because it did not go from decreasing to increasing. Okay, so let's label these out. Local max occurs. So occurs is going to be x values. Local max. Now I know it says local. That means critical. There's two different words they could use here. Local means critical. Okay. They'll most likely ask critical on the test. Okay, where does it occur? It occurs a maximum. They occur at, I don't know, about -4.2, about -4.2, and around 2.3 or so. Okay, guys. Now let's also talk about the local max value. So that's where the y happens to be for these things. So the y critical max would be at around like, I don't know, 0.5. We'll just say it's a half. And then where is the max value for this one? Looks like it's about 3.5. Okay, then it says local mins occur at. Okay, so where are the mins? Now there's only one min, one critical min, and it occurs right there. We'll just call it -2. It's really close to -2. So x equals -2, and where is the value at? I don't know, it's a guess, maybe like 0.25, so y equals -0.25. Okay, the absolute max, okay, that means that these can count. The endpoints can count. Absolute max occurs at, so x value, because it's where it occurs, maximum, that would be right here, and we said that that occurred at 2.3. And what was the y value we said it had? It said it had a absolute max value of 3.5. Okay, the absolute min occurs at. Okay, now this is a critical min, but remember these endpoints are both further down, this one being the furthest down, so that is the absolute min. And it occurs at 4.5, it looks like. And the absolute min value, so what is the y value for it? About -2.5. Okay, and there we go. That is everything for this lesson.